Welcome to the session. I am Dr. S. Anusha Kathyayani, Assistant Professor in Department of Chemistry, Institute of Aeronautical Engineering, Hyderabad. Today, we are going to see two different types of batteries, which are namely zinc air battery and another one is lead acid battery. We are going to see the both types with their introduction to zinc air batteries and the construction of zinc air battery and working and chemical reactions and the advantages of zinc air battery as well as the construction, working principles and the advantages and disadvantages of lead acid batteries. So coming to the introduction, these zinc air batteries are the metal air batteries. The name itself indicates zinc and air. The zinc is a metal and air. So the metal air batteries activated by the oxidizing zinc with the oxygen present in the air. So these batteries have high energy densities and also relatively inexpensive to produce, means to manufacture. So these range from the smaller to the bigger size, from the button cells to the larger size, which are used in film cameras and also in electric vehicle propulsions. So they are activated, they become static, they become activated by the supply of air. So from the air it grabs the oxygen and then it got activated. So it was absorbed into the electrolyte present inside the battery through a membrane. So typically it reaches full operating voltage of around 5 within 5 seconds of exposure to air. So after immediately exposure to the air it start working, because the oxygen present in the air diffuses into the membrane electrolytes. It diffuses through the membrane into the electrolyte of the battery and it start activating. So oxygen diffuses directly into the battery. So it utilizes an electrolyte that catalytically promotes the reaction of oxygen without being depleted or transformed of this membrane during the discharge process. So it composed of zinc and alkaline electrolyte. Here it is a metal air which is a zinc and air combination and with an electrolyte which is the alkaline electrolyte. So it varies in different sizes starting from the coin to the cameras and even electric vehicle propulsions. Here there are two types which are rechargeable and non-rechargeable batteries. So zinc air batteries are not rechargeable and whereas zinc air fuel cells are rechargeable air batteries. So here this is the zinc which is the anode and this is the air. So it supplies the oxygen through the membrane. This is the membrane. So we can see here the porous electrode which gives the OH minus, this is the air. So it enters into this is the membrane. So it gives the oxygen which enters into the membrane, then it got activated through into the electrolyte, then it got activated. So what is the construction and working principle of these batteries? Here the primary are non-rechargeable batteries. It comes under the primary batteries. So the button cell type and one AH type are secondary rechargeable. So anode is loose granulated zinc. This is the metal which are going to use in the zinc air batteries. It is a loose granulated zinc is used. Cathode is porous carbon plate and electrolyte is alkaline electrolyte which is called potassium hydroxide. So here KOH is used. Here this is the zinc batteries. Here the anode can C is the anode. This is the anode can. A is the separator. So which is nothing but the membrane, and B is the zinc powder anode. This is the B. This is the zinc granulated porous zinc powder. And C is the anode can and D is the insulator gasket. Here this blue color one is the D is the insulator gasket and E is the cathode can and F is the air hole. So this is air hole to provide the oxygen supply, and G is the cathode catalyst. Here this is the cathode catalyst and H is the air distribution layer. So here to the air entered will enter into the membrane through a layer. So which is the air distribution layer and current collector, and I is the semi-permeable membrane. This is the semi-permeable membrane. So this is the semi-permeable membrane through which the oxygen from the air will enter into the electrolyte. So the electrolyte is KOH and it enters into the KOH and got activated, and thereby it reacts with the zinc metal present in the battery. So what is the working principle? Here in zinc air battery, the oxygen from the air reacts at the cathode and forms hydroxyl ions. So the oxygen enters into the membrane, there it is going to convert into hydroxyl ions by reacting with the cathode, which migrate into the zinc paste and forms zincate. So here we are using zinc. So zinc is converted into zincate, which is ZnOH4 2 minus, releasing electrons to travel to the cathode. So here the electron release will be happen, that electrons will move to the cathode. So the zincate decays into zinc oxide and water. So thus formed zincate will be converted into zinc and water, which returns to the electrolyte which is present inside the battery, that is called KOH. So the electrons move to the cathode where this is converted, zincate is converted into zinc oxide and water. So the water returns to the electrolyte which is KOH. The water and hydroxyl ions formed from the anode are recycled at the cathode. So here what happens? The water, the H2O molecules and the water H2O molecules and OH minus ions from the anode are recycled. So continuously formation will happen. Again it will go to the cathode. There it again zincate formation. Zincate will again converted into zinc oxide and water molecules. Then this process will happen continuously. So the water is not consumed. Due to this process formation, due to this recycling process, the water is not consumed here. Here we can see the zinc is reduced first to zinc 2 plus 2, oxidized first to zinc 2 plus 2 electrons. Thus, zinc oxidized zinc reacts with the 4 OH minus ions, results in the formation of zincate. Again, this zincate is again converted into zinc oxide and water molecules with the release of 2 OH minus molecules. These OH minus molecules, here we can see the oxygen first entered to the porous membrane, which is the oxygen plus water reacts and then results in the formation of hydroxyl ions. These hydroxyl ions again enter into the electrolyte. There it is going to react with the zinc ions, metal ions. Here the oxygen plus water plus 2 electrons gives rise to HO2 minus and OH minus ions. So this is the reaction going to happen where the oxygen reacts with the water molecules, results in the formation of OH minus ions. Thus formed OH minus ions going to react with the zinc metal, which is a metal used in these zinc air batteries. There it is going to activate the zinc and result in the formation of zincates. Thus formed zincates, which is ZnOH4 taken twice, OH4 2 minus, is going to reduce or is going to again dissociate into zinc oxides and water molecules. So the reaction produces a theoretical voltage of 1.65 ohms and is reduced to 1.35 to 1.4 volts in available cells. Here the working, here we can see here the oxygen molecules are going to react. Here this is the overall reaction. Here the zinc OH minus molecules are going to react with the zinc ions and then it forms the zincate. So the zinc thus formed zincate is again converted into zinc oxide and this water molecules. So this process is continuous and thus there is no water consumption over here. And this is the overall reaction because here this is the zinc anode and zinc is Zn2 plus is formed with the release of 2 electrons. Again the air entered from this layer. the air entered from this semi-permeable membrane is got reacted with the OH minus ions, resulted in the formation. It reacted with the H2O minus H2O molecules and results in the formation of OH minus ions. Thus formed OH minus ions are going to here. This is OH minus. So this zinc plus OH minus ions result in the formation of zincate. So Zn OH4 2 minus zincate ions. These zincate ions, this is zincate. Again, it was converted into zinc oxide and water molecule plus 2OH minus. Overall, our reaction is 2Zn plus O2 gives rise to 2ZnO. So again here, the oxygen from the oxygen plus water molecule gives rise to 4OH minus ions, and zinc plus zinc is reacted with the 4OH minus ions, and then zincate formation, and then zincate formation with the release of two electrons. Thus formed zincate is again dissociated into zinc oxide and water plus 2 hydroxyl minus OH minus ions. The overall reaction is 2Zn plus O2 gives rise to zinc oxide, to ZnO oxide, ZnO, which is zinc oxide. Here the 4 OH minus ions are going to dissociate into O2 plus 2 H2O with the release of two electrons. Again, here the ZnO plus H2O plus 2OH minus ions, this is the zincate. Again, this zincate is again gained 2 electrons and it was converted into zinc plus 4OH minus ions. The final overall reaction is 2ZnO is gives rise to Zn plus O2. So this is the reaction is going to take place inside the zinc air battery. So the working, if we see here at cathode, of oxygen molecule plus water molecule plus 2 electrons, which is the formation of 2 OH minus ions. E naught is 0.34 volts. It happens at a pH 11. So in the fluid, the zincate is going to convert into zinc oxide and water molecules plus 2 OH minus ions. Whereas at anode, this zinc by reacting with the OH minus ions, this zincate formation with the release of 2 electrons, where the EMF is negative, E naught is equal to minus 1.25 volts. Here the overall reaction, the final reaction, if we see 0.34 and 0.34 minus 1.25, the overall reaction is the 2Zn zinc plus oxygen gives rise to zinc oxide, which is a E naught of 1.59 volts. Here, what are the applications of zincate batteries? They exist in very small size to very big size. In coin cell batteries, they are used in calculators, pacers, used as a power source in hearing aids. Here we can see the hearing aids. This type of batteries are used. They also used in electronic pacers and used in military radio receivers and used in voice transmitters. So these batteries have wide applications. Depending upon the usage and application, these batteries are preferred. So coming to the advantages, the weight not necessary to carry a secondary reactant here. Coming to the weight aspect, and it is high energy density and competitive with the lithium ion. Inexpensive material and safety, even it don't require a volatile material, so zinc batteries are not prone to catching fire compared to lithium ion batteries. They have a capacity to prone fire, but unlike lithium ion batteries, these zinc have a safety and no need to worry because they don't require any volatile materials and it won't prone to catch fire. So the excellent shelf life with a self-discharging rate of only 2% per year. This is why it is preferred because of the more excellent shelf life. So because of more shelf life, these batteries are preferred and available in a range of sizes, which is from coin to large cell sizes, and rechargeable high power cell fuels in this process of development. It is under the research category. These rechargeable high power fuel cells are going to develop. So construction of a lead acid battery. So the another type of battery which is called lead acid battery. The name itself indicates here we are using lead and acid in this type of batteries. The a lead storage battery that is used in automobiles and inverters. In households, all inverters are lead acid batteries. Here it which can be recharged a limited number of times. So they are rechargeable, but they are restricted to some times. The lead storage battery consists of a lead oxide which acts as a negative terminal, and the cathode is lead grid packed with lead dioxide. So the lead grid it is here. These are the battery consists of 6 2-volt cells connected in series. Here each component cell is composed of several negative and positive electrodes made up of pure lead and lead oxide respectively. The electrodes connected in parallel, here we can see the electrodes are connected in parallel, are immersed in a solution of electrolyte which is nothing but the acid, because lead acid. Here we are going to use the acid is sulfuric acid which is H2SO4. Here both anode and cathode are separated by insulators, are also called glass fiber sheets or wood or rubber. It may be they are separated by the insulator, which may be a glass or which may be a fiber sheets or which may be a wood or rubber sheets. These lead plates fits in between the lead dioxide plates. So here the lead dioxide plates will be there. Here we can see blue color with lead spongy lead which is in lead is in spongy structure, and lead oxide which is red color. These plates are all immersed in H2SO4 solution. The sulfuric acid with a concentration of 38% is used as an electrolyte. To immerse in these plates inside this 38% sulfuric acid is used as an electrolyte. The oxidation and reduction reactions takes place during charge and discharge process. So the reactions. So what are the overall reactions going to happen in the lead acid battery? Coming to the anode, lead is first oxidized to Pb2 plus with the release of 2 electrons. So which further combines with SO4 2 minus ions. Here H2SO4, what happens? It dissociates into H plus and HSO4 2 minus. Here the here these ions are going to react with these sulfate ions are going to react with the lead. Here lead oxidizes to Pb2 plus and 2 electrons. This Pb2 plus and SO4 2 minus gives rise to lead sulfate, and again the overall reaction is lead plus sulfate ions gives rise to PbSO4 minus SO4 plus 2 electrons. This is the reaction at anode. Coming to this discharging reaction in at the cathode, the electrons released from the anode. Here the first at anode lead is converted into Pb2 plus and 2 electrons. It got oxidized. So thus release of electrons. Oxidation is nothing but the loss of electrons. Reduction is nothing but the gain of electrons. The electrons released from the anode flow towards the cathode. So here the PbO2, the lead oxide present in this cathode, gains electrons to form again Pb2 plus ions. So the reduction at cathode from plus 4 to plus 2 oxidation state. So Pb2 plus ions combine with the sulfate ions. Again here the reaction is PbO2 which is at the cathode get 2 electrons from the anode and 4 H plus ions from the electrolyte will converted into Pb2 plus and 2 water molecules. Here again we got Pb2 plus. Again this lead ions will react with the sulfate ions, will give the PbSO4 which is lead sulfate. The overall reaction will be lead oxide plus 4H minus plus 2 electrons will give 2 electrons plus SO4 2 minus from the sulfuric acid. So SO4 2 minus from the sulfuric acid will give rise to lead sulfate and 2 water molecules. So this is the overall reaction at the cathode. So coming to the overall reaction at anode as well as at cathode. So the lead plus sulfate ions gives rise to lead sulfate plus 2 electrons. Again from the lead oxide, here the lead sponge and lead oxide we are used in the battery. Again at cathode, lead oxide plus 4H minus, these two electrons from the two electrons from the anode and SO4 2 minus from the sulfuric acid all got reacted and gives PbSO4 plus 2 water molecules. Coming to the overall reaction, lead from anode, lead oxide from cathode plus H2SO4 from the lead from anode, lead oxide from the cathode and H2SO4 from the electrolyte gives lead sulfate plus 2H2O plus energy. Here E naught is 1.685 volts and here E naught is 0.36556 volts. Here lead oxide is converted into lead sulfate. Here lead sponge is converted into lead. Here if we see here, uh, here this is negative terminal and this is the positive terminal. The electron released will move here and here gained by this. So again the lead oxide plus 2 electrons will converted into Pb2 plus and again lead sulfate. Here we can see PbO2 plus 2 electrons plus sulfate ions will give rise to PbSO4 plus 2H2O. Here from where? Here this 4H minus ions and H2SO4 again converted into H plus and SO4 2 minus ions. So thus formed H plus ions and sulfate ions will move and react with the lead oxide which is converted into lead sulfate. Here also the sulfate ions present in the electrolyte will react with the lead sponge means which is Pb. That lead sponge is again first oxidized to Pb2 plus by releasing 2 electrons. That electrons only transferred to the positive terminal which is called cathode. Then it is converted into lead sulfate and the overall reaction is this. So here lead plus lead oxide, this is from the anode, cathode, electrolyte. So gives rise to lead sulfate and water molecule with energy delta E. Okay. So this is the overall reaction. So the recharging reactions in lead acid battery. Recharging is done by applying a voltage across the electrodes that is more than it is greater than 2 volts. So this recharging can be done by applying more than 2 volts across the electrodes. So the current flow in opposite direction, that is the battery can deliver at anode. Pb2 plus ion will consume the electrons to reduce to lead. Here the reaction, the PbSO4 minus SO4 plus H plus 2 electrons, the lead sulfate formed is again gaining the 2 electrons and it is again getting 2 electrons, then Pb plus SO4 2 minus ions are formed. So at cathode, the PbSO4 reacts with the water and gives off electrons to PbO2. So here this is at anode. This process is anode. And at cathode, what happens? This lead sulfate reacts with the water molecules, gives rise to lead oxide and 3H plus ions and HSO4 minus and 2 electrons. So during this recharging process, the current flows in the opposite direction. The lead sulfate again splits into lead and Pb plus SO4 2 minus ions. Here the lead sulfate plus water gives rise to lead oxide plus 3H plus ions. Here this is the overall reaction. Lead sulfate plus 2H2O water molecule plus energy gives rise to lead. Here the lead from anode, lead and then lead oxide and 2H2 H plus and HSO4 which is 2H2SO4 sulfuric acid. So maintenance of lead acid battery. If the lead acid batteries are properly maintained, they can function for a longer periods and a longer times. It depends upon the maintenance. So we should avoid over discharging of the battery, means we should not keep the batteries up to the very low battery level. So we should not avoid we should avoid. So the discharging of the battery has to be checked frequently and maintain the electrolyte, which is the sulfuric acid, at a proper level by adding the water and keep the battery clean and avoid overheating the battery. So coming to the uses of lead acid battery, so the applications in automobiles, which are like cars and buses and motor vehicles, and also used in gas engine ignition and telephone exchange, and even in the hospitals. It is used as an UPS, which is an uninterrupted power supply, which is uninterrupted power supply UPS as a backup of power. This is about the batteries, namely lead acid and zinc batteries. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.